When you deposit money in a bank account, the bank pays you interest for the right to use your money for a period of time. Principal, P, is the original amount of money deposited. Interest is calculated based on a percent of the principal. That percent is called the interest rate, R. Time, T, is the number of years money is deposited. Simple interest, I, is interest calculated only on the principal.
The fact that simple interest is based on principal makes it quite simple to calculate because you accumulate the same amount every year. That's really simple.
Suppose you deposit $400 in a savings account and keep it in the bank for 6 years. The annual interest rate is 5%. Identify each value in the simple interest formula.
The simple interest formula in words is interest is principal times rate times time. When we use the equation to represent interest, we use I. To represent the principal, we use P. To represent the rate, we use R. And to represent time, we use T. Now in this situation, our principal is the initial amount we deposited, which was $400. Our rate is the percentage rate. And when we substitute the percentage into our equation, we always use the decimal form of the percentage. In 5% written as a decimal is 5/100ths. The time is the number of years, and right here it says 6 years, so we'll use 6 to represent time. Now to figure out the interest, we have to calculate all of these numbers. So 400 times 5/100ths is 20, and 20 times 6 is 120. So that is our interest.
Suppose you deposit $500 in a bank account that earns simple interest at 1 2/10% per year. You keep it in the bank for 2 years. Which of the following is or are true? The principal in an account plus the accumulated interest is the balance.
If we look here to figure out what the balance is, let's go ahead and look at year 1. The balance formula, you'll see it written as B equals P plus I, which is the balance equals the principal plus the interest. So year 1, our principal is $100 and our interest is $2. So that means our balance at year 1 will be $102. And we can do the same thing here to figure out after 2 years. The balance is the principal, which is $100 plus the interest, and we can see it is 2 plus 2, which is 4. So that means the total balance at year 2 is $104. Now what would be the interest here for year 3? Well, you can figure out the exact same way. You do the principal plus the interest, and that will give us our balance. So the principal is $100 plus our interest is $6. So that means at the end of year 3, our balance will be $106.
I wonder if you might be interested in opening a CD account.
CDs? Who buys CDs anymore? I get all my music online.
A bank manager wants to encourage customers to open a certificate of deposit, or CD account. He decides to make a poster to show how much interest a CD earns over time. Help the manager complete the table.
To help us solve this problem, we are going to use the simple interest formula, which is interest equals principal times the rate times time. Our principal is the initial deposit, which is $2,500. So we'll substitute that into our equation. Now our rate is the 3.5%. Now, when we substitute that into our equation, we have to remember to convert our percentage to a decimal. Percent to decimal, you divide, or you move the decimal point 2 times to the left, to the left. So 3.5% written as a decimal is 35 thousandths. Now our time for year 0 is 0. So then I go ahead and multiply. When I multiply these two numbers, I get 87 and 5/10. And then I have to make sure I multiply that by 0. And any number times 0 is 0. So that means the simple interest for year 0 is $0. And the account balance, remember when you get the balance of something when we're dealing with simple interest, the balance formula is balance equals principal plus the interest. So the principal is the $2,500 plus the 0 interest we made at year 0 is just $2,500. For year 1, we're going to do the same thing, use the simple interest formula, which is interest equals principal times rate times time. Our principal is $2,500. Our rate is the 3.5%, and remember to represent it as a decimal when you substitute it into your equation. Our time is years, which is 1, and then our interest is unknown. That's what we're trying to figure out. When I multiply these two numbers, I get 87 and 5/10. Then I have to multiply that by the years, which is 1, and anything times 1 is just that number. So that means my interest at year 1 would be $87.50. And to figure out my balance, I am going to use my balance formula, which is balance equals principal plus the interest. So my principal is $2,500 and the interest is $87.50. So when I add that together, I get $2,587.50. So that will be my balance at the year 1 mark. For year 2, we'll use the exact same equation, and I will use 2 for the time because that's the number of years, and our interest is unknown. When I multiply these two numbers, I get 87 and 5/10, and I have to make sure I multiply that by the number of years, which is 2. And when I multiply that, I get 175. So $175 represents the interest at year 2. Now to figure out my balance, I'm going to use my balance equation, which is balance equals principal plus the interest. The principal is $2,500 and the interest at year 2 is $175. Now I need to go ahead and add that together. And when I add that together, I get $2,675. So that would be the balance at year 2. Year 3. We have to make sure we use 3 for the time. And then when I go ahead and multiply these two numbers, I get 87 and 5/10. And I have to make sure I multiply that by 3. 87 and 5/10 times 3 is 262 and 5/10. So that means the simple interest at year 3 would be $262.50. Now I need to figure out my final balance by using my balance equation, which is balance equals the principal plus the interest. Our principal is $2,500 and the interest is $262.50. Now when I add those two together, I get $2,762.50. And $2,762.50 represents the new balance at year 3. Do the same thing, use my simple interest formula. When I multiply these two numbers together, I get 87 and 5/10, and we have to remember to multiply that by 4 because that is the time. And when I multiply 87 and 5/10 by 4, I get 350. So 350 represents the simple interest earned at year 4 mark. Now to figure out my balance, I'm going to use my balance equation, which is balance equals the principal plus the interest. And the principal is $2,500 and the interest is $350. When I add those two together, I get $2,850. So $2,850 represents the balance at year 4. Now let's take a look at this. Let's see if we notice a pattern from year 0 going to 1, 2, 3, and 4. So from year 0 to year 1, we see it increased by 87 and 5/10. And from year 1 to year 2, if we go ahead and subtract these two numbers, we get 87 and 5/10. Now to go from 175 to $262.50, that's an increase of 87 and 5/10. And to go from year 3 to year 4, we see it increase $87.50. So what does that look like? When everything simplifies to the same thing, that is considered what?
Hey, we're filling in a table again. Notice that the simple interest formula maintains a proportional relationship between time and simple interest earned.
All right, so this relates to proportions. Now, when we did this before, we learned that a proportional equation is y equals mx. So remember, m was our constant of proportionality. So looking at this, what will be considered the constant of proportionality? So in this case, the constant of proportionality will be the 87 and 5/10. So we can technically write a proportional equation. So it would look like y equals 87 and 5/10 x. Now what will be considered the y? Will that be the time or the interest? Well, in this case, remember, y is the dependent variable, and we know time is always the independent variable. Time depends on no one. So that means time is our x value, and then our interest is our y value. So this is how it will look if we were to write this as a proportional equation.
A new bank customer with $5,000 to deposit looks at the manager's poster. The customer wants to open a CD to earn money for his retirement. If he wants to have $5,500 in the CD, how long does he need to keep the account?
All right, we will figure this out the exact same way we did the example. And instead of using $2,500, we'll use $5,000 as our principal. So we're going to substitute that information into our equation. $5,000 will be our principal. Our rate will be the same. And let's go ahead and figure out what our interest will be at year 1. So now I need to multiply the 5,000 times 3.5%. And when I multiply those two numbers, I get 175. And then I have to multiply that by 1. Any number times 1 is itself. So this means at year 1, the interest that will accumulate is $175. Now, just like before, we noticed there was a pattern. We figured out what the constant of proportionality was if we related to that. Here, it was $87.50. So that means each year increased by $87.50. So if we change the principal to 5,000, we figured out at year 1, the interest will be $175. So that means each year, since this is simple interest, each year interest will increase by $175. So year 2, we know the interest that will accumulate is $350. And if we add $175 to that, we get $525. And if we add $175 to that, we get $700. So now we need to answer this question. It says, if he wants to have $5,500 in the CD, how long does he need to keep the account? So here, we know he started with $5,000, but we want to have $5,500. So at year 1, the balance will be $5,175. $75. At year 2, it will be $5,350. That's not enough. Year 3, it will be $5,525. So that's at least $5,500. So it's going to take 3 years to reach that goal.